In this lesson, we show how different type of variables and constants are allocated in virtual memory map, and we present the stack frame structure. The knowledge of these concepts are critical to the understanding of buffer overflow attack. In this simple program on the left side of the view graph, we have two variables. BUF is a 32-byte character array. The compiler will read this and try to allocate to the memory area in the .bss region, because this is for uninitialized kind of variable data. Bn, on the other hand, is a pointer point to a structure called structure node. And in 32-bit architecture, the size of a pointer is 32-bit, 4 byte. And Bn will be allocated 4 byte right above the BF array, character array, by the compiler. And here in the middle of the program, you see there's a constant string, hello world. When compiler sees that, they will reserve a corresponding number of characters in the .data region. They are considered to be initialized program data, and which is right below the BSS region or segment. Note that the constant in the data region cannot be changed. The BUF is a global variable, Bn is a global variable. They can be changed. However, when we try to copy data into buffer, the data will go toward the higher address space as they increase the pointer. And therefore, you cannot override the data, the instruction in the .txt region. When we copy the data into buffer, the only way to write is in direction upward to a higher address. Therefore, the instruction in the txt segment are protected, they are safe. The distance from .bss segments to instruction in share library is so huge, right? We are talking about the share library is starting at 470 address space, right? Therefore, it's very unlikely we are going to see such a long copying. The design of the memory layout is to allocate the variable used by the function and subroutine inside the stack. This includes the actual parameter passing in from the calling program to the callee. And local variable declared inside the function will be also allocated in the stack frame. In this program, we have a string 1 that is passing in as a parameter. It is a pointer to a character array, therefore it's a 4 byte address, and we need to allocate at the top of the stack frame. And after that, we'll typically allocate the program counter, stack frame pointer, and followed by whatever the local variable. And in this case, the local variable is a 32-byte character buffer, which is named A. And both A and string 1 are allocated in the user stack frame, but in different regions, right? Later, the function use allocate malloc function to reserve a memory area in the heap with a structure of called node and in the heap area. And when the malloc function is returned, it will have the same memory size as the structure. And the address is the first byte of the address is returned and saved in that global variable Bn. And therefore, after the malloc, the Bn will contain an address point to the memory area in the heap area in the runtime. Here we show the typical structure of the stack frame. It contains the actual parameter followed by the return program counter. That's an address that will be retrieved by the CPU to set the next to bring in the next instructions in the calling program. Followed by the stack frame pointer, we will point to the stack frame, and when the function return, this address will be retrieved and set to the stack pointer register. And after that is a set of local variable used by the function.